Okay, so here is the third problem that we're going to work. This is discussion, week 4, example 3. Okay, so we have member BA, which is a steel bar. So I just kind of start writing stuff down. A steel bar with a cross-sectional area of 1.75 inches squared. And if I didn't know, like, does it mean like it's a cross-sectional, like square, whatever? Look at the unit. That is units of area. And a yield strength of 50 KSI. What's yield strength? What does strength mean? I don't know what that is. Units tell me it is stress. It's KSI. So I can see it's a bar, and I can see that we're going to be pulling down. These are going to be tension members pulling up. So it's a normal stress of 50 KSI. Okay, member BC is a pair, so that means there's two, see the two aluminum bars, having a combined cross section of 4.5 inches squared and a yield strength of 40 KSI. And again, I know it's normal. I know it's stress because it's KSI, and I know it's normal because I can see that this is going to be a two-force member, right? A factor of safety of 1.5 is with respect to the yield is required. So that means my allowable stress equals my yield divided by 1.5. So I have 40 divided by 1.5. And when I look up here, my allowable is my yield divided by 1.5. So I have 50 KSI divided by 1.5. Okay. For both. So I have, this one was 50, this one, okay, 40. Determine the maximum allowable load P that can be applied to the structure. Okay, so again, I'm looking at normal stress. Normal stress equals normal force over A. I am told the normal stress. I am told A. So what I'm actually going to be finding then is what is the maximum normal force that can be in this rod? What is the maximum normal force in this rod? And how does the normal force of BC and the normal force of BA, how do they relate to this unknown load P? So where do I start? Where do I always start? Every single time, force P. Force, we can call that normal force BC. Normal force BA. This is at 55 degrees, so I can use static. I can find that relationship between P and my normal forces. So let's sum forces in the y direction, and I'm going to have minus P plus NBC sine 55 equals 0. Sorry, I'm trying to get another video started over here because they take forever to process. Okay. So I can find then that NBC equals P divided by sine 55. Okay, so look, I have this equation. Okay, I have an equation for the stress of BA equals the normal of BA times the area of BA. And the stress of BC equals the normal of BC divided by the area of BC. And I found that the stress of BA is 50 KSI divided by 1.5 equals the normal stress in BA divided by 1.75 inches squared. Okay, I also have over here the stress of BC is 40 KSI divided by 1.5 equals the normal force of BC divided by the area, 4.5 inches squared. So I have now related that normal force in member BC to my unknown P. If I go plug this back up into here, look at that. I can solve for P. That's going to be the maximum force P I can have according to my criteria. Now let's sum forces in the x direction. It equals 0. So I have NBA, okay, minus plus NBC cosine 55 degrees equals 0. NBA equals NBC cosine 55. And look at this. NBC is P divided by sine 55. and then cosine 55. And I've just now worked through my system where I have both the normal force internal as a function of P. So I go back to my stress equation, and I'm going to have 50 over 1.5 equals NBA, P divided by sine 55 times cosine 55, okay, divided by 1.75, and I can get that the value of the maximum P that I can have for BA, so this is going to be the maximum P I can have for BA, is equal to 83.3 kips. And now I'm going to do the same thing over here. I have 40 KSI divided by 1.5, that's my factor of safety. Okay, so here's my stress, here's my factor of safety, equals the normal stress in BC divided by 4.5 inches squared. And I have that normal force in relation to P. So I have 40 divided by 1.5 equals P divided by sine 55 divided by 4.5 inches squared, and I get P based on the limiting values of bar BC to be 98.3 kips. So I have a force P that causes failure of BC, and I have a force P that causes failure of BA. So it says, what is the maximum, okay, the maximum allowable load P? Do I want to choose the 98 or the 83? Okay, I have to understand the maximum load I can actually apply to the system without going over my failure criteria. My failure criteria is 83.3 kips. And at 83.3 kips, what is my stress? My stress is going to be 50 divided by 1.5. I maxed it out, okay? Because I'm only going to 83.3, the stress in bar BC is not going to make it up to 50. So I could actually go back and find that stress because I now have this value that I'm going to use, 83.3 divided by sine 55, okay, divided by 4.5, and I can actually tell you then the stress that's in BC. And it will be less than this value because we are using a much smaller load, okay? So again, it's the only equation we have is stress equals force over area. You are either going to be given an allowable stress in an area and you have to find the normal force, or you're going to be given the normal force in the area and you have to find stress. I mean, this is all you have. And I can see it gave me the stress. I can see it gave me the area. I have to find in. How do I find in? Statics. It's all statics. I can go back, draw a free body diagram, and find the relationship between this force P and the load that's in that bar. And then I'm going to go with this smaller. So the answer is 83.3.